Question 4.1 has 6 parts related to the 3 reactions. Here are the reactions we have called T, W, R, and S, A, B, C, and D. First, we need to give the IUPAC name of substance B. In reaction 1, substance B is the only product formed when a hydrogen halide reacts with an organic compound. When 2 substances combine to form one new product, this is an addition reaction. Addition reactions happen when a substance has a carbon-carbon double or triple bond, which can open up to add on 2 new substituents. The product, compound B, has one less bond between those 2 carbons because one of the bonds broke open and 2 new atoms were added on, specifically a hydrogen and a bromine from the reactant hydrogen bromide. But we do not yet know how long the carbon chain is in these compounds. But in reaction 2, which also starts with compound B, we can see that the product has a 4-carbon chain. Since it has a hydroxyl group, this product is an alcohol, namely butan-2-ol. The hydroxyl group in butan-2-ol came from the hydroxide ion in sodium hydroxide. And from this we can deduce that the hydroxyl group must have replaced or substituted for the bromine atom in compound B. So reaction 2 is a substitution reaction. So compound B must have a 4-carbon chain. Because the bromine is on carbon 2, it is 2-bromobutane. This is a haloalkane. And the halogen is bromine. Next, we need the name or formula of compound C. Since bromine was replaced by a hydroxyl group, it would have formed sodium bromide in solution. Next, we need to use 2 names to describe the type of reaction happening in reaction 1. We have already said this reaction is an addition reaction, and working backwards, we can deduce that the reactant would have been a 4-carbon alkene since it produced a 4-carbon alkane. Now substance A is more likely to be but2-ene instead of but1-ene, since but2-ene is symmetrical, and so will only form one structural product, that is 2-bromobutane. If substance A was but1-ene, it would form 2-bromobutane and 1-bromobutane. Let's fill in the structure of substance A in reaction 3 because it also appears there. Now we still need a second name for the type of reaction in reaction 1. Since a hydrogen and a halogen are added, this reaction can also be called a hydrohalogenation reaction. Next, we need the name or formula of substance D. We can see that in reaction 3, a hydroxyl group and a hydrogen are lost, forming water. We could instead say water was eliminated. As a result, a double bond is formed. We can say that water was eliminated or that dehydration occurred. Now, concentrated sulfuric acid is a dehydrating acid and is able to remove water from a molecule. Then we need the structural formula of compound A, which we have already seen is this structure here, but2-ene. Lastly, we are told that 2-bromobutane can form but2-ene in one step, and we need to know the reaction conditions or reagents to do this. Treating a haloalkane with a concentrated strong base, such as concentrated sodium hydroxide, forms an alkene. The base removes or eliminates a hydrogen and a halogen. This is a type of elimination called a dehydrohalogenation.